Quantum computing is next revolution. Quantum computing is poised to be the next revolution in the field of computing. With its potential to solve complex problems exponentially faster than classical computers, quantum computing represents a paradigm shift that could revolutionize various fields ranging from cryptography to drug development. This video will explore the fundamental principles of quantum computing, its potential applications, and the challenges that need to be overcome for its widespread adoption. Understanding quantum computing's fundamental concepts. To comprehend the significance of quantum computing, one must delve into its fundamental concepts. Unlike classical computing's reliance on binary bits, quantum computing utilizes quantum bits or qubits, which exist in superpositions of various states simultaneously. Quantum superposition and entanglement allow qubits to process information in parallel, providing immense computational power unparalleled by classical computers. Quantum computing and its computational power. Quantum computers possess an extraordinary computational power, enabling them to solve complex problems exponentially faster than traditional computers. Algorithms such as Shor's algorithm for factorizing large numbers and Grover's algorithm for searching databases demonstrate quantum computing's superior computational efficiency. These achievements hold great promise in fields like cryptography, optimization, and simulation, where traditional computers often fall short. Quantum computing's potential impact on scientific research. Quantum computing holds immense potential for advancing scientific research further. By simulating quantum systems accurately, scientists can unravel mysteries related to material properties, chemical reactions, and the behavior of subatomic particles. This could revolutionize the drug discovery process, material design, climate modeling, and the understanding of fundamental physical phenomena, opening new frontiers in various scientific disciplines. Quantum computing's implications for cryptography. Cryptography, a critical aspect of secure communication and data protection, faces a significant challenge with the advent of quantum computing. Quantum computers can potentially crack currently used encryption algorithms, rendering traditional cryptographic techniques obsolete. However, quantum computing can also help in developing more robust encryption methods based on quantum key distribution and quantum-resistant algorithms, ensuring data security in a quantum-powered world. Quantum computing and machine learning. Machine learning, a rapidly growing field, stands to benefit greatly from quantum computing. Quantum machine learning algorithms have shown potential in tackling large-scale data analysis and optimizing complex models. Hybrid approaches combining classical and quantum techniques could lead to groundbreaking advancements in natural language processing, data clustering, and classification. Quantum computing's potential in optimizing supply chains. Quantum computing's massive parallel processing capability and optimization algorithms can address the challenges faced in supply chain management. The ability to quickly analyze and optimize distribution routes, inventory management, and scheduling of resources can lead to more efficient and cost-effective supply chains, reducing waste and increasing overall productivity. Quantum computing for climate modeling and prediction. Climate change is one of the most pressing global challenges. Quantum computing's computational power could revolutionize climate modeling, allowing for more accurate predictions and analysis of complex climate systems. These predictions can help policymakers and scientists develop effective strategies to mitigate the effects of climate change. Quantum computing for financial modeling and risk assessment. The financial sector can immensely benefit from quantum computing's ability to simulate complex financial models accurately. Quantum algorithms could enable faster risk assessment, portfolio optimization, and fraud detection while analyzing large amounts of financial data. This could revolutionize decision-making in finance and ultimately lead to more efficient and stable financial systems. Quantum computing and cybersecurity. The rise of quantum computing poses serious threats to current cybersecurity infrastructure. Quantum machines' immense computational power might break encryption algorithms, endangering data privacy and security. However, quantum computing could also pave the way for developing more secure cryptographic methods. Collaborative efforts between quantum computing researchers and cybersecurity experts are crucial to ensuring a quantum-safe future. In conclusion, quantum computing holds transformative potential across numerous domains. Its ability to address complex problems, revolutionize scientific research, strengthen data encryption, optimize various processes, and aid in climate modeling signifies the forthcoming revolution in the computing world. The implications of quantum computing are vast, but their realization depends on ongoing advancements, collaborations, and further understanding of this extraordinary technology.